I tricked you. I tricked you. There's more to part B. It's on the back. Just flip over the paper. We're going to be talking about common radian measures. Common, these are the ones that you're going to have memorized because these are going to go on our handy dandy unit circle. Okay. First, we're going to learn it in parts. Here we're going to first learn where things are located. When we are going around the unit circle, think about this as literally a pie, right? But it's not just one pie, it's actually two pies. And it's going to blow your mind because you're like, but it's only one circle. Yeah, it's only one circle, but pi is only half of this circle. Okay? Pi is only half of this circle. And I'm going to tell you why. Remember how we said that pi radians are related to the circumference, right? If I was to take a circumference of a circle with a radius of 1, that's just 2 pi around the entire circle, correct? So 2 pi would be me going around the entire circle. So therefore, 1 pi is me only going around half of the circle. Does that make sense? You're with me? Okay, cool. If I am at negative pi over 4, that means that I rotated clockwise. The negative tells me I went clockwise, right? So the negative tells me I went clockwise. This is telling me that I'm taking my pi, going clockwise, and dividing it into what? Fourths. So if I take my pi and go clockwise, so we're going this way. That's our rotational direction. And I'm going to divide it into fourths because, again, 1 pi is only half of the circle. So if I was to divide this into fourths, this is a half. This would become a fourth. So this is where negative pi over 4 would reside. Pretend that I equally split that. Because if this is a whole, this is a half, then this would be a quarter. Does that make sense? Okay. This one says it's positive, so we're going to go counterclockwise. And what does it want me to do with pi? Divide it in half. So again, this time we're now going counterclockwise. And with that counterclockwise pi, we're going to divide it in half. So dividing this in half puts us where? At the half, smack dab at y. So this is pi over 2. Because we took our pi. Remember, pi is only half of the circle, even though pi's are, yeah. Okay. All right. Now on this one, it wants us to take our pi and we're dividing it into how many parts? 3 parts, right? So we're taking our pi and dividing it into 3 parts. And of those 3 parts, we want to stop at the part that is the 2/3 of it, right? So this again, it's positive. So we know we're going counterclockwise. That's how we know. Boom, counterclockwise. And we're now dividing that 1 pi into thirds. I'm not going to do such a great job, but pretend that I did. So I think that's pretty good. They almost look like equal parts. Yeah. All right. So this would be 1/3 and this would be 2/3. So the angle stops here at 2 pi over 3. So for all of them, I'm going to go through and put in where my angle resides. So this right here would be what we call negative pi fourths. Okay. This right here would be what we call pi over 2. This right here, from here to here, that's what we call 2 pi over 3. Your x-axis is always your initial side, and where you stop is called your terminal side. Initial is where you begin, terminal is where you terminate, where you stop. You always start at the positive x-axis. Yes. When I'm going this way, this is 0. When I'm going this way, because the full round is 2 pi. Your starting point is going to be 0. All right. So how does this relate into things that we see on a daily basis? Well, think about the hand on the clock, right? The minute hand on the clock travels how many radians in 5 minutes? In 5 minutes. So let's think about it. At 5 minutes, I'm what out of how many total minutes? Out of 60. So I've traveled 5 minutes out of 60 minutes. What does that reduce to? 1/12, right? So now I've traveled 1/12 of a full 60. Well, a full 60, remember we said that's 2 pi, right? So therefore, this is 1/12 of, mathematically means we are multiplying. 1/12 of 2 pi. Does that make sense? Let me draw the circle. Here's my clock. Here's the center. My minute hand would be here at 5, right? Agree-ish? I know we don't have analog clocks around here, but hopefully we know that 1 is 5, right? I know I don't have an analog. Oh, it's in, I do. It's in the think tank. But this is 1. So I've only traveled 1/12 of this circle. Does that make sense? I've only traveled 1/12 of this circle. So in terms of radians, I've only traveled 2 pi of the entire radians. Like I'm only traveled 1/12 of 2 pi. And of means I'm doing what mathematically? Multiplying. So I'm only a fraction of this has traveled. So therefore it's 1/12 of 2 pi, which equals pi over 6. So I've traveled pi over 6 radians in that time. Just for poops and giggles at the top of your paper, right? What about after 15 minutes? What would be the radians? So looking at what we just did, the top of your paper, what would be 15 minutes in terms of radians? Listen, what'd you say? You said what? What does 15 over 60 reduce to? And then 1/4 of 2 pi is what? Pi over 2. Okay. You're not traveling the whole circle. So like I'm only traveling a piece of the circle. So therefore I can't say it's 2 pi. It's a piece of 2 pi. And of mathematically means we are multiplying. So therefore it would be, like you said, 15 over 60 is 1/4. So I then would travel 1/4 of 2 pi, which reduces down to pi over 2. Okay. 2 pi is if you went around the entire circle. Okay. And we did not. All right, what is the measure of theta in radians if x equals 45? So I'm giving you degrees. When you have degrees, is there a rule I can already follow? There is. There's a rule I can already follow. So we have 45 over 1 times what? Over 180. 45 and 180, can I pre-reduce? What are they both divisible by? Even. And 9, let's go a little higher. Divide by 9, divide by 9. What is 45 divided by 9? 5. What's 180 divided by 9? Now can I reduce some more? Yes, what is that? What is 5 over 20 reduced to? Pi over 4. No, is it just x equals 45? Because it's asking for x. They're asking for this piece. That means we make it a negative. It didn't. Oh, it said. Oh, I saw that. Yeah, you're right. You see nothing. Yes, this is x. So if x is pi over 4, then how do we find the remaining theta? Theta would equal, what did you say? 2 pi minus pi over 4. All right. How do we subtract and add with fractions? They must have what? The same denominator. So if I wanted this to have a denominator of 4, what do I have to multiply by? 4, right? I'm going to teach y'all really quick, chopsticks in a bag. If finding common denominators isn't your thing, chopsticks in a bag is going to be the fastest way to get it done. You just cross multiply. 2 pi times 4. 8 pi. Your rice that you're eating is negative. 1 times pi is pi. All in a bowl. 1 times 4 is 4. There you go. You don't have to worry about it. You can do it. Be done. Again, if you want to see what that means, if I have 1/2 minus 3/7, and I want to quickly subtract this without having to find a common denominator, I'm doing chopsticks in a bowl. So you have 1 times 7, 7 minus 2 times 3, which is 6, all in a bowl, 14. What's 7 minus 6? So the fraction would be, the answer would be 1/14. Okay. My teacher called it bats in a bag. I decided that I didn't like that, so I call it chopsticks in a bowl. Because that made more sense to me than bats in a bag. So yes. Go 11th grade, Shauna. All right, what's 8 pi minus 1 pi? So what's left would be 7 pi over 4. That would be our theta. All right, let's take it back to geometry. What is it called when two angles are on a straight angle? Supplementary. So we know that these two things are. Did I spell that right? It looks wrong, but y'all said it's right. Perfect. They're supplementary angles, okay? Remember we said that half of a circle is actually what? 1 pi, right? Half of a circle is actually 1 pi. So we know that 5x plus x has to equal pi. Heather. All right. What's 5x plus 1x? 6x equals pi. How do I get x by itself? Divide both sides by 6. So we know that x equals pi over 6. So therefore, the other angle would be, theta would be 5 pi over 6, because 5 times pi over 6 is just 5 pi over 6. All right, so the whole purpose of this practice is for you to get used to using radians and understanding in game. All the way around the circle is what radians? 2 pi. I know we think pi and we think just 1 pi is a circle. It is not mathematically. That's in food and baked goods. Notice that they have an extra letter in their word, that E, that's what separates us, okay? So our pi, which is just pi, and so when you go around the circle, that is 2 pi. Got it? We're not talking about pies, all right? I did have a really good apple pie last night, though.